Look up at the night sky and you see planets moving across the stars. Mercury, Venus, Mars, Jupiter, Saturn, all following their own paths around the sun for billions of years. With so many large objects moving at enormous speeds in the same general area, you might wonder, why don't they ever crash into each other? It seems like it should happen all the time. But in reality, planets colliding is extremely rare. In fact, the last major planetary collision in our solar system happened billions of years ago, the giant impact that formed our moon. So what keeps everything so perfectly organized? The answer is a beautiful combination of physics: gravity, inertia, angular momentum, and the way orbits work. Let's break it down simply. Every planet is constantly falling toward the sun because of gravity, but at the same time, it's moving sideways at exactly the right speed. This sideways motion, called tangential velocity, keeps it from falling straight into the sun. Instead, it falls in a curved path, an orbit. This balance between gravity pulling inward and inertia trying to go straight creates stable elliptical orbits. Now, why don't these orbits cross and cause collisions? Because the solar system is not chaotic. It's highly organized. All the planets orbit the sun in roughly the same plane, the ecliptic, and in the same direction, counterclockwise if viewed from above the sun's north pole. Their orbits are almost circular and spaced out at very different distances from the sun. Mercury is closest, then Venus, Earth, Mars, then the asteroid belt, then Jupiter, Saturn, Uranus, and Neptune. The distances are huge. Even Earth and Mars, our closest neighbors, are on average 225 million kilometers apart at their closest approach. That's more than 500 times the distance from Earth to the Moon. But distance alone isn't enough. The real reason they don't collide is orbital mechanics and gravitational stability. Each planet has its own specific orbital period and speed. Earth takes 365 days. Mars takes 687 days. Jupiter takes almost 12 years. Because they move at different speeds and are at different distances, they rarely line up in a way that would cause a dangerous close approach. Even when planets do align in the sky, conjunction, they are still millions of kilometers apart in three-dimensional space. Gravity also plays a protective role. The giant planets, especially Jupiter, act as cosmic vacuum cleaners. Their massive gravity perturbs the orbits of smaller objects and either ejects them from the solar system or captures them as moons. This helped clear out most of the debris after the solar system formed. The solar system is not static. It's dynamic, but it's in a stable equilibrium that has lasted for 4.5 billion years. There was a period early in the solar system's history called the Late Heavy Bombardment, when collisions were much more common. But once the planets settled into their current orbits, the system became remarkably stable. Mathematicians and astronomers have run long-term simulations of the solar system for millions of years into the future. The results show that the orbits remain stable for at least the next several billion years, with only very small variations. Of course, nothing is eternal. In about 5 billion years, the sun will expand into a red giant and swallow the inner planets. But until then, the planets are remarkably safe from colliding with each other. So the next time you look at a model of the solar system or see a diagram of planetary orbits, remember, it's not just pretty pictures. It's a delicate, self-regulating dance of gravity and motion that has kept our cosmic neighborhood peaceful for billions of years. The planets don't crash into each other not because of luck, but because of elegant physics that was set in motion when the solar system formed. What do you think? Did you know how stable our solar system really is? Or were you surprised by how much empty space there is between the planets? Drop your thoughts in the comments. I read every single one.